talking about derivative, we're going to have this scheme of work that is from derivative, the principle, up to the inverse strict function. Come, let's start with it. Derivative is represented as what? Gy over gx. Or it can be represented as what? F prime of x. Or on the other side, we can represent by what? G of f of x. And that is how we represent derivative. Hence, if you see g somewhere, just know that it's derivative. Okay, moving then to the constant rule. What's a constant rule? That is derivative of a constant is equals to 0. Like derivative of a 1 is equals to 0, or derivative of k is equals to 0. Like take it a look at it. You have gy all over gx of k is equals to 0. But if you have gy all over gk of k is equals to 1, you ask the equation, why is the difference? Because of this x. Because here is with respect to x, and x here and k here is a constant because there is no x there. But in this case, it's with respect to k, and k is included, that is 1. And gy all over gx of 1 like this is equals to 0. Take that into consideration. Okay, let me move on to another part, that is the power rule. The power rule coming on with what? G all over gx of what? X to the power n. Okay, using the power rule here, we are going to do what? Bring down this n, and that will be x to the power n minus 1. And what are we going to be having? X to the power n minus 1 all that times n. Here is the power rule. Moving then on to the sum rule. A sum rule, addition, okay, or subtraction. If you have g of gx of f of x plus g of x, that will be equals to what? We differentiate separately by separating f of x and g of x. And I'm going to be having what? G of gx of f of x plus g of gx of g of x. Okay, we are having that separately. That's what we are going to be having. And from here, we can have what? F prime of x plus g prime of x. Yeah, that's what we have at this point. Okay, what in case if you have a negative here is negative. Just take here, being a negative, okay, display. In case you take here is negative, hence, we are going to have a plus or minus, we are going to have a negative here. We are also going to have a negative here, in case that was subtraction. Moving then to the quotient rule. What's a quotient? Take a look at it. A quotient is 1 all over another thing. Example, you have y is equals to what? U all over v. That's an example of a quotient. Okay, we have y is equals to u all over v. If we differentiate this, we are going to have what? From the basic principle, the law is what? Gy over gx is equals to what? V gu minus u gv all over v squared. That is the principle of the quotient rule. U all over v, we have this all over that. Hope you understood this principle and how it works. Then move then to another part, that is the product rule. What's the product? uv. Okay, y is equals to u times v. If we differentiate this, we are going to have what? Gy over gx is equals to what? U gv plus v gu. We are going to have simpler example in this case. And a typical example here can be what? Sin x all over cos x. And a typical example here will be what? Sin x times cos x. That's an example of a typical example. We're going to apply this principle to have the final answer. Okay, moving then to chain rule, let's just erase at this point. Okay, at the level of the chain rule, what's the chain rule? Okay, a chain rule occurs at the example you have for f of j of x, or okay, something like that, f of g of x. How can you differentiate what's inside here? Because it's not f of x, because this x is equals to what? J of x. Something like that, just take it like that. Or f of y, something, so it should be clean. Is y is equals to j of x. And how can you differentiate what's inside here? You are going to be using the chain rule by taking what? U example is equals to this j of x. Therefore, y, because we can take into consideration that y is equals to this, just erasing what we wrote here. Therefore, we take into consideration that y is equals to what? Y is equals to what? F of u. Okay, then we differentiate gy all over gu is equals to what? F prime of u. And on the other case, we take this du all over gx is equals to g prime of x. Hence, gy all over gx is equals to what? Gy all over gu times what? Du all over gx. Because at the end, we want to have a gy all over gx so that this u and this u will cancel. And then when you having what? We take this and multiply, that will be f prime of u times g prime of u of x. Okay. That is how it actually functions. You're going to have a typical example at the end when you're going to be done with inverse function. You're going to have a typical example while going up. Is actually how it look like. Therefore, looking at higher power of x or higher order, that is second order derivative. Okay, a typical example is if you have what? F of x is equals to what? X squared. We differentiate the first time to have what? F prime of x is equals to what? 2x. We have to differentiate the second time, that is the higher order, as f prime of x is equals to what? That will be equals to a 2. Normally using the derivative principle. Hope you know about that. And before solving this, you need to know about trigonometry. Otherwise, take a look at the video of trigonometry. This is what we're going to be having at this point using the higher power of x. And in law, f prime of x is equals to what? Gy all over gx. But f prime of x is equals to what? G square y all over gx squared. You can move further and differentiate and differentiate and differentiate. Let them differentiate common function of x. Common function like what? Sin x, cos x, tan x. We always use these three functions. Derivative of sin x, dy all over gx, or g all over gx of sin x is equals to what? Cos x. And that of cos x, g of cos x all over gx is equals to what? Minus sin x. Yeah, I know you don't know really about this. I'll show you how to have this easily. And that of tan x is equals to what? Sec square x. Okay, how do we have the derivative of sin x easily? Using this circle, we have sin x, cos x, minus sin x, and minus cos x. Yeah, that's how it look like. If you differentiate, you are going to have what? Cos x. From sin x, we have cos x. If you differentiate cos x, you are going to have what? Minus sin x. If you differentiate minus sin x, you are going to have minus cos x, just negating it. And if you differentiate minus cos x, you are going to have what? Sin x. And in case we have integration, that is integration is just like the reverse process of derivative actually. If you integrate, you are going to be coming back here. You are going to do about integrative in another video. Today you are focusing on derivative. And if you do that, you are going to come back here. As the inverse of it, we do like this for a derivative. And this like integral. That is how the symbol of integral is this one. Okay? Put this into your head and take that into consideration. Let's just erase at this point and move then to the third part. Then the third part is what? We are going to look about exponential logarithm. Example, the first one is e to the x. E to the x, okay? Exponential e to the x. How do you differentiate this? You are going to differentiate and have e to the x actually. Yeah. If you have g of e to the x all over gx, you are going to be having what? E to the x. How does this happen? We can take u is equals to x, but a typical way to do that is what? We differentiate what is up here and put it here, that will be 1, and recopy it. Example, if you have e to the 2x, okay, we have to solve it out. The derivative of this all over gx is equals to what? We differentiate this 2x and have what? A 2, and recopy back what we had earlier, that is e to the 2x. Let's prove it using the chain rule. We are going to take u is equals to what? E is equals to 2x. Gu is equals to what? 2. Okay, moving on then, we are going to have what? Y is equals to e to the u. And if we differentiate e to the u, we are going to have e to the u. Therefore, gy all over gx is equals to what? E to the u. Okay, therefore, gy all over gx, sorry, here is gy all over gu because it's with respect to u. Therefore, gy all over gx is very simple and easy to get it because it will be equals to what? E to the u. And e to the u times what? That will be g1 over g times u all over gx. That is this one, g all over gx times 2. Therefore, we are going to be having what? 2e to the u, and u is equal to what? 2x. You see that we came back to what we said earlier. Let's take a look at something better. We'll come out with the typical formula that we want to master, or we are going to be using while solving this. A typical formula can be what? If you have e to the f of x, if you have y is equal to e to the f of x, the derivative of this is equal to what? Gy all over gx is equal to what? F prime of x e to the f of x. That is very typical. Let's move down to logarithm. That is li of f of x. Take that. Here, the principle is that you do what? Now, the derivative of this is equal to what? How do you differentiate this? You are going to have this typical formula again. That is f prime of x all over f of x. That is how the derivative of ln happen, and that is for e. Example, if you have ln of x, the differentiation this we are going to differentiate x, that will be 1 all over x. You can use the chain rule to prove this wrong, this right, by using u is equal to x and further simplifying, and you are going to come out with the same thing as earlier. Just say g all over gx here, and you are having this as the final answer. I think you understood about the formula and you know how it's going to, so that in our other video when you are going to be solving and skipping steps, you are going to know exactly why and how we did that. Talk about implicit derivative. What's about implicit derivative? Oh, that's something tricky. If you have example x squared plus y squared is equals to 0, and you're asked to equals to 20, they just put 20 so it should be constant. Okay, something like that. And you're asked to differentiate this. What comes in your mind is an x and a y. How are you going to do that with respect to x? Okay, with respect to x, this will be equals to what? To x using the power rule. But if you differentiate this one, how are you going to do that? Because there is a y. The basic rule or principle we are going to use here, we are going to use the power rule still and have what? To y. But we are going to put gy all over gx, and that is equals to a0. The question you're going to ask me is, why am I putting gy all over gx? Oh yeah, usually when you have a equation like derivative of 2x, usually what we have is what? Y is equal to 2x. You understand? Just like an implicit function, because if you bring this here, you're going to have y minus 2x. It's just looking similar to this one. But when you have at the end is what? You have gy all over gx is equals to 2. Meaning you differentiated this function with respect to x. That is why you had this. And on this other side, you put gy all over gx. That is exactly the same thing you have here. If you had like y squared is equals to 2x, differentiating this, you are going to have what? 2y gy all over gx is equals to 2. Therefore, gy all over gx is equals to what? 2 all over 2y. That is equals to what? 1 all over y. And what is y? 2x. Okay, you see that at the end the derivative of this come down to this. Hope you understanding what we actually did here. Yeah, I'm sure. Let's move then to inverse trig function. What do you know about inverse trig function? Let's take a look at it. Okay, by inverse trig function, the name, that is sine inverse, cos inverse, and tan inverse. The basic trig function we know, that is sine inverse of x, or arc sine x, cos inverse of x, and tan inverse of x. The question I want to ask is differentiating this. How are you going to do that? Yeah, watch it. We take for the first one, y is equals to what? Sine inverse of x. How are you going to differentiate this? That's the question I'm asking myself. Okay, let's watch it. Having an idea? Oh yeah, I'm sure. We have to differentiate this. How can we do that? If you say sine y, that will be equals to what? Sine of sine inverse of x. Typically, that is how it happened. Because if you put sine here, you are going to put sine on the other side. And hence this sine and sine will cancel out. Therefore, you are going to have what? Sine y is equals to what? X. Yeah, you saw that magic? I'm sure. Hence, we are going to differentiate this because we want to have gy all over gx. Differentiating sine x, we are going to have what? Cos x. Therefore, we are going to have cos x gy all over gx, because we respect to x is cos y, sorry. because here is y. Cos y gy all over gx is equals to a 1. Therefore, our gy all over gx is equals to what? 1 all over cos y. Yeah, we are already moving on, but we know that cos y is equals to what? Because we have a sine here and we have a cos, we can bring it back. Actually, we know that cos y plus sine y all square is equals to 1. Therefore, our cos y is equals to 1 minus sine square y, all this, the square root of that, and sine y is equals to 1. From here, we know that sine y is equals to x. Therefore, sine square y is equals to x squared. And then hence we are going to have 1 over the square root of 1 minus sine square y, that is x squared. Therefore, gy all over gx is equals to that og of sine inverse of x all over gx is equals to 1 all over square root of 1 minus x squared. That's amazing, and that's the answer. Let's do focus on this other part of the board. Let's just put here. We have cos, that is cos inverse of x. Okay, is equals to y. Hence, we can do the same thing that we are going to have what? Cos y is equals to x. Okay, we differentiate this, we are going to have what? If we differentiate cos, we are going to have minus sine. Therefore, we are going to have minus sine y is equals to what? 1. Therefore, y is okay, we put the gy all over gx here. Therefore, gy all over gx is equals to what? 1 all over negative sine y. We come back to the basic principle. We have what? Cos square plus sine square is equals to 1. Therefore, sine square is equals to what? 1 minus c square, square root of that. Okay, or sine. Hence, we are going to have what? That will be equals to what? 1 all over, or negative 1 all over the square root of 1 minus cos square y. And cos square y is equals to what? Coming back here, is equals to x. That will be equals to what? Minus 1 all over square root of 1 minus x squared. And that is exactly what we have. Meaning the difference between the derivative of sine inverse of x and cos inverse of x is negative. It's negative at the denominator here. Take that into consideration. Let us move to the last part, that is tan. Okay. In case you have a tan, let's just erase this one again. You have a tan. That is y is equals to a tan inverse of x. Therefore, we can apply the tan as area g. That will be tan y is equals to what? X. Yeah, hope you know why we put this like this. Okay, if we differentiate tan y, we are going to have what? Sec square y gy all over gx is equals to 1. Therefore, gy all over gx is equals to what? 1 all over sec square. That is typically what we have. And from basic trigonometry, we have what? Sec square y is equals to what? 1 plus tan square y. That is the principle. Hope you know about trigonometry. We'll check the video that will drop up here to know about the trigonometry. Okay, we have this, and you just have to substitute here. You are going to have what? Gy all over gx is equals to what? 1 all over 1 plus tan x is tan y is equals to x. Therefore, you're going to have x squared. And we come to the end of this section. Then move then to question solving. Okay, let's erase all and do some basic derivative and basic question. Okay, we are going to do some random question starting from the beginning. That is the constant rule. We said for a constant g of a constant k, well, this is just like a recap, is equals to 0. That's what we said. Moving then to power rule, that is g all over gx of x to the power n is equals to what? N x to the power n minus 1. That is how it look like. Okay, that is how it look like, x to the power n. Okay, then to some rule, if you have f of x, if you have y is equals to